sure. So can I share my PowerPoint presentation now?
I'll introduce you, and then I'll kind of hand over to you.
Yeah, sure.
Kind of hand over to you. Yeah.
Yeah.
We are live, sir.
Okay. Good evening, everyone, and we are back again with another program on our page, Haryana chapter of AIOTA, and I have today with me Dr. Karthikeyan Krishnamurthy, and he is a very dear friend. We met in a coursework in 2013, and we have very fond memories of studying together, spending some time together. Karthik, as I call him lovingly, he's an amazing scholar. He is frustratingly hardworking. I've seen him work very closely. He is very dedicated towards academics, something that can really inspire you. So without much of a time, I welcome you, Karthik. And if you have few lines about yourself that you would like to put in front, I had sent everybody the suggested reading, and I also sent everybody a little bit of profile that you had sent me already. However, if you would still want to like to start with one of few lines with about your work or about your research work, and you can then start with your talk as well.
Yeah. Thank you, Manish. And I'm really very honored to be here to share my research work in this very good platform. And yeah, basically I'm an occupational therapist, and then after having a much of clinical experience, I started off looking at it was like enticing me what is actually happening the children's brain, especially the children with autism's brain. But there are so many avenues which cannot be explored while I was in India. So then I wanted to pursue my higher education, and then I was really interested in looking at the brain activities and doing research kind of thing, especially do real neuroimaging techniques to introduce that techniques to in the context of children with autism, especially in India, is very scarce. So I wanted to pursue in that area, and it was really progressing well. Yeah, of course, because of this pandemic reasons, we have some itch and blips over there and here. And despite the fact that we are progressing well enough for our research topic. So this is what my introduction, and you can find more about my research work when I'm going through the contents of today's presentation. So thank you once again for Manish, and then for those who are all participating here. I really welcome you all for this wonderful evening. Yeah.
I wanted to once again reiterate something that you already told us, that anybody who wants to ask a question may not really wait. They can just kind of ping us, raise their question as we are going on the go. So you can ask your question anytime. Okay.
Yes.
Okay,
Yes. Basically, yes. It's a kind of, it's not a very complex thing, but for those who are very new to neuroimaging and then looking at the brain activities and in terms of connectivities, the terms are all very new for, especially the people who are in India. They haven't been explored much on that. So if you have any question on the spot, please raise your question so that we can clarify immediately. No need to wait until the session gets completed, and then the contents will not be understandable. So yeah, feel free to ask the question if you come across anything. So may I go now?
Yes, please. You can share your screen. Yeah.
Thank you. So
yes, I think yes, your screen is visible now.
Okay, visible. Okay. Let me put it in the full. Yeah. Is it full now?
Yes, of course.
Full screen, right?
Full.
Okay.
Full.
Okay. Full. Thank you. So, so today's topic is, okay, once again. Okay. So today's topic is, as everyone knows, it is a neural basis of temperamental effortful control and is response to transcranial electric stimulation in individuals with autism. So what I'm going to present today, everything seems to be a little bit of new terms, like a temperamental effortful control. As an Indian occupational therapist diaspora, we haven't explored much on this area. And also, the transcranial electric stimulation is one of the fewest things which has been arising across the worldwide. So I'm going to explain these two things in a little more detail as the presentation goes on, especially in terms of the children with and the individuals with the autism perspective. So without further delay, let me give a brief introduction about what is effortful control. So this is like a funny kind of things. We are very much fond of the cricket, watching cricket and playing cricket, especially being an Indian citizen. It is one of the religious kind of thing what we have to engage in with that. So just imagine today, I mean, we have a very exciting match. Like all our Indian players are extremely powerful. I mean, are in the great form. So does the Sri Lankan players. Like where the match happens in the 2011 final World Cup. So simultaneously, so today is a match, but unfortunately tomorrow is one of the most, I mean, the exam, the career path. So what is our initial, the habits and all? Probably we tend to choose one of the three habits. For example, like a low scorer habit. It doesn't mean actually that we are getting low scorer, but however, our habits define what the output will be. For example, yeah, we know that it is an exciting match. We cannot control our impulses on watching cricket, but unfortunately, we also have know the importance of studying for the exam and getting scores high. So this is being a student's life. This is one of our most productive activity in our life perspective. So when we stick with our habit, for example, just by prefer watching cricket without even studying, probably we tend to get a low score. Yeah. And in the second scenario, sometimes we are not able to control our impulse of watching cricket. And we also look at our future in terms of our passing the examination. So our habit would have been watching cricket for a time being, and then studying simultaneously. So this is our second habit that we have. So as a result of that, we probably end up with getting moderate scorer, like a grade B or something. And in the third scenario, we tend to stick with only study and without even watching the cricket even for one single over during our exam time. So probably this habit would yield more score, like a high scorer of getting grade A plus or above. So basically, being a student life, high scorer habit is equal to high productivity in life. So this is the most productive activity that every students and their parents are willing to get. So now we take a look at, we know that low scorer habit and moderate high scorer habit and the high scorer habit. So basically, is there any question?
No, not
I'm
yet.
hearing a sound. Okay. I'm hearing a sound. Okay. So let's take a look at what is the mechanism behind. I explained earlier the common scenarios that the people tend to have when they have two options together, like a life-saving versus life enjoying. Now, I'm going to explain a bit of behind what is the mechanism of low scorer habit and moderate scorer habit and high scorer habit. For example, if you tend to watch cricket alone without studying, probably they give excessive attention towards an unpurposeful task or stimuli. For example, they realize. I think they don't even realize that what is the importance of getting high scorer in the examination and what is the life perspective, and then they don't know how to inhibit their overarching stimuli. Overarching stimuli means which is something, the stimuli which is something enticing, but it is unpurposeful for the task that they are engaged in. And then um, when they keep on watching the cricket, they don't even know how to control and how to monitor their own habits. So, for example, how much time that they tend to give for watching cricket, how much time they tend to give for studying. Uh, that particular skill is actually monitored by executive attention, which is a specialized unit of brain function in terms of cognitive skill. And the people with the low scorer habit probably have no more execution of such kind of attention to monitor that habits. And in a moderate high scorer habit, people they tend to watch cricket, and also they realize that the examination is very important. So they also want to study simultaneously. So they can switch the task between watching cricket and studying simultaneously together. As a result, they probably end up with the grade B, like a moderate score. And here the mechanism would be they are able to switch the attention between the purposeful and unpurposeful tasks. For example, the purposeful is studying simultaneously, and then the unpurposeful task would be the watching cricket. So here they tend to control their impulses towards the overarching stimuli in a partial way, but not in a full efficient manner. And also, they are able to aware of what their time is being spent on the task that they have in hand. So that is called the partial monitoring habits. In contrast, the high scorer habit, people probably they have excessive attention towards the purposeful stimuli, and they have very good inhibitory control over the impulses that they are receiving or coming from an enticing or interesting stimuli. Even if they comes and then they get diverted, they immediately switch their attention back to the task that they have in hand, which is very purposeful for their life. So this is, they have both complete inhibitory control and monitoring of their own habits in terms of executive attention. So this is the basic mechanism behind, cognitive mechanism goes behind their, based on their habits, habitual information and situation that they come across. And now, this executive effortful control would be defined as the part of executive attention, part of inhibition, plus part of flexibility. Altogether is called as effortful control in a layman terms. It is also defined as scientist. There was a scientist from University of Wisconsin. She is Dr. Rothbard and Ruda, and they defined as the executive effortful control as the efficiency of executive attention. Executive attention means monitoring. That includes the ability to inhibit a dominant response, which means inhibiting the overarching impulses like watching cricket, and or to activate a subdominant response, which means they have to activate, switching from from watching cricket to studying. That is a subdominant response, which is very purposeful for their life. And also, they have to plan and detect errors. Plan means how much time they have to spend for particular task, and then how much, even if they are like a high scorer habit, even if they are shifting from one task to the other task, they immediately know what time they have to, how much time they can spend on particular task, and then immediately switch their unpurposeful task towards a purposeful task by detecting the errors in time monitoring and planning the sequence. So it is all called as effortful control. So basically, we have three subcomponents in effortful control, such, for example, effort, as I mentioned earlier, executive attention, inhibition, and flexibility. So moving on. So why this effortful control is important in our life? because there are so many researchers have been explored the effortful control areas in the normal typical circumstances, and how they is actually helping for the human being to acquire some of the most I mean life helping skills. For example, this effortful control is associated with academic achievement and better teacher-student relationship. This is very much important for the children, especially when they are pursuing their education and starting their the career. So when they have the higher effortful control, they probably would have, not probably, they might have better academic achievement and also the teacher-student relationship. And then second skill, it associated with the pro-social behavior. That is, it helps and protect others, including volunteering and generous giving of resources, including money. And some people, you might have heard about, some people, they just give the land for school education or building the school, or else for religious activities like a temple. They don't really bother about the cost of the land just by it's a kind of generous act. So probably they might have better effective control, and it also helps to achieve the better social competence. Yeah, it means it helps to make effective social interaction, and also able to form a harmonious relationship with other people. And it is also helpful for us to respond adaptively in a social in various social settings that they come across. And then negative emotionality. Research is also supported the effortful control is closely related to negative emotionality. In that aspect, when someone is experiencing or reacting with the negative emotions such as fear, anger, or sadness or anxiety, if the people tend to have a better effortful control, they can able to better control their negative emotions altogether, so that it makes the people's life so easy with other people. And it is also found that it is closely linked with the empathy-related response. This means to understand other people's emotions and perspectives, so that when you find some people are really struggling for their life, you probably tend to give or helping other people. So you relate their feelings immediately, and then start giving offering your help in a timely manner. And finally, this is our own research paper. We also find the higher effortful control also helps the people to become socializing with other people, and also identifying various emotions like sadness, happiness, anger. Yeah, they are able to identify those emotions and react them accordingly. So overall, it helps to improve the socialization. This is our recent research which we published in a few months ago. Yeah, moving on. We actually saw so many positive impacts of effortful control in different life skills. So now someone might ask, what happens if there is any deficit in the effortful control? Yes, it is probably affecting various areas. For example, if the people tend to have low deficiency in effortful control, they tend to have behavioral issues. For example, they tend to show a lot of temperaments and injuring others and disobeying the rules in both formal and informal settings. And it is also found that effortful control deficit is closely related to maladjustment. That is, they are not able to cope up with the stress under stressful conditions, both in exclamatory and then environmentally, and they don't even make effective relationship with the others, and that actually hinders for them to perform well in the society. And effortful control deficit is also related to internalizing issues. For example, as I mentioned earlier in our research studies too, they are not able to control their own impulse, like anxious, depressive, and somatic compliance. And externalizing issues is also another aspect where the effortful control deficit is closely linked with. So it is closely related to behavioral issues too, like externalizing problem, like showing an aggressive act towards the public platform and breaking rules. Too often you can see these issues with the behavioral issues together. And finally, because of this deficit, they also have social and emotional dysfunctions too. So moving on, now, we found that effortful control is a component of executive attention, inhibition, and also flexibility, meaning they have to switch the attention from the purposeful to non-purposeful and vice versa tasks. So some people might have asked, what's the difference between effortful control and executive function? Because the executive function is also overlays some of the components. So for example, inhibition, flexibility, working memory, and some other aspects of like attention. So if they overlaps together, what is the real difference between effortful control and executive function? For them, yeah, the research from this group of people, they mentioned it is a review paper. Actually, I would suggest if someone is really interested in to looking at the differences, I suggest you to go through this research article. They actually pointed out five areas where the effortful control differ the executive function. Number one is a developmental pattern. In terms of developmental pattern, the effortful control appears much earlier in life. For example, some of the components of the effortful control, like executive attention and its component, one of the primary component is the orientation skill, that actually develop from year one and consistently grows until the year of 3. But in the effortful control, in executive function, all the components, there are 8 more components in, 8 components are primarily involved in the executive function, but all of them are started growing after 3 years only, and they consistently grows until 13 years of old. And the second domain, in terms of working memory involvement, there is no role in effortful control, but there is a huge role in executive function. And in terms of emotion dependency, effortful control and its component much relies on using emotion in various contexts so that they can perform better, and then they can obtain the skills what they require for initiating. And for the executive function, there's no emotion dependency involved, but as they grow older, they tend to know, based on the development of effortful control, if it can help them to contribute in terms of identifying and reacting with the stimulus in the older age as they tend to grow older. In terms of adaptive function, yeah, there are so many activities, like not activities, the adaptive function, like I mentioned earlier, social emotional regulation, academic achievement, like getting higher grades, and then a teacher-student relationship, and then maintaining and consistently monitoring the task between the purposeful and unpurposeful stimuli. So there are so many ways the effortful control is linked with the life, peoples of life in adaptive function. But in executive function, it's probably very narrow, just by limiting the theory of mind. Like theory of mind means how you have, the person has to think with relates to other people's mindset. So that is called the theory of mind. And also the research also found the executive function is closely linked with the school readiness. For example, planning, taking lunchbox and getting all the routines regularly, and then keeping up the homework schedules. So for these kind of skills, effort executive function is much more useful to develop. And in terms of neural substrates, I mean the brain, which is responsible for maintaining the effortful control function and executive function. Although I'm going to explain a little bit later, just as a matter of fact in the information I'm giving now, prefrontal cortex from the lateral side, which is very dominant brain region for effortful control, and also the anterior cingulate cortex is another brain region which is responsible for better effortful control. In terms of executive function, the orbitofrontal and prefrontal cortex, both in ventral and dorsal aspects, are responsible for playing these skills.
Karthik, we might have a question. Mona, do you
Yeah,
have a question?
yeah,
Yeah,
yeah, yeah, yeah.
Karthik,
Please
it's
go ahead.
good information. I have one question. The
Yeah.
one question that you have already answered is at which age we develop effortful control.
Yeah.
So I still have this question that do we develop it as early as a year? 1 year?
You mean effortful control by
Executive
giving it
effort.
some therapeutic intervention?
No, 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 no.
Naturally. She's
Developmentally.
asking developmentally.
No. It appears only after 1 year.
Yeah, after a year also we develop this,
Yeah,
where we
yeah.
know we can control the and what is actually related to it is it's genetically you develop, or external factors also affect how you have been brought up, environmental
It's
factors also affect.
Yeah, it's a nice question because I sent you the paper for your pre-lecture reading. It also mentioned that the genetic from the parents influences the effort control development hugely from one aspects, and in the other aspects, the environment is also plays an important role for developing the effortful control, especially the component of executive attention and flexibility. If we give more opportunity for the children, for the baby to perform, their effortful control function would become better.
Okay.
Yeah.
So it develops much before you can check the emotional caution or the social caution, and it has a indirect effect on that as well, right?
Yes.
Okay. Thank you.
Yeah. Welcome.
Please go
Shall I
ahead.
go for next? Yeah.
Yes, please. Yes.
Okay. So now we look at the background of effortful control and its implication and its deficit. What happens if there is any deficit? Now we have further questions. So what we saw earlier is a study of effortful control in typical individuals. So what happens in individuals with autism? Is there any effortful control deficit registered in individuals with autism? And if so, what are the brain regions are involved the effortful control deficit in individuals with autism? And if any deficit is registered in terms of brain substrates like subcortical and the cortical regions, is there any treatment which directly implicate the modulation of brain activities? So we are going to address all this question in a different study. So we actually perform each question as a separate research study. Let's take a look at one by one. First, in the first question, is there an effortful control deficit in autism? Yes, we actually published this research paper as you see in the screen, the effortful control deficit and the prefrontal cortex functioning in children with autism a month ago. And it was clear that the children with the ASD showed significant deficit in EC, and EC means effortful control, and its related construct like executive socio-emotional function as compared to the typical developing counterparts. I actually sent you all this paper. Probably you might have read about this and the procedures that we used for recording the prefrontal prefrontal cortex and analyzing the prefrontal cortex functioning. So I do not want to go much of the detail for this paper which I published. So if anyone is really interested in knowing about what is inside, I ask them to. It is a open access journal, so you can download it freely and go through this paper. So yeah, this paper is actually we investigated the effortful control deficit in children, but we also yeah, this is the second paper that we are writing about it. Yeah, using another task. Earlier, we for children we tend to use the working memory task, since it is highly validated task for children. So we used that one. So we also collected data for adults with the autism. So in this study, we haven't published this study, but we are writing to it. It is in the final checking process. So yeah, in that we actually recruited 10 adults with the ASD and 13 adults with the typical control in the age range between 18 to 24 years, but the mean age they fell into 19.07 for children, adults with the ASD. For typically developing controls, they have 19.18. The mean age range. Yeah, it is also IQ matched. The samples are also IQ matched and also gender matched. So what we look at, what is differing from the paper that we published for children with the autism and the adults with the autism. The adults, the two questionnaires, for example, in children, we used the early adolescent temperament questionnaire for looking at the effortful control function. But here in adult study, we use the adult temperament questionnaire. It is basically the similar form like the early adolescent temperament questionnaire, but the way that the items means questions arranged is quite different from these two forms. For example, this is also other than that, it is also a standardized self-reported questionnaire. The early adolescent temperament questionnaire is not the self-reported one, rather the parents of the children reporting their behavior and habits. This consists of 19 items, which has been arranged in the similar scale like EATQ, such as attention control, activation control, and inhibitory control. Differing from the EATQ, this questionnaire has a 7-point Likert scale, but in EATQ, early adolescent temperament questionnaire, is just a 5-point Likert scale. So both the scales actually gives the interpretation of if the scores are getting in one component, which means that they have the better control over the specific function. Like if they have received more scores on attention control, they have the better attention control. Similarly for all other subscales. And the second thing, what is actually differing from the one that we conducted for children with autism, we actually investigated the IQ, the intelligent quotient, using the Wechsler scale of intelligence for children. But here we use the test of nonverbal intelligence. That is another difference. So basically, this is also a standardized measure. We usually call in a short form Tony 4. Fourth edition means 4. So it is also a validated measure, a powerful measure for investigating the general intelligence and problem solving and abstract reasoning. This consists of two equivalent forms. Equivalent form is one of the way that checking for the validity and reliability. So if the person can do one form differently, the other forms in another way, probably it is not much reliable. So if the if the person can perform both the forms equally, which means they are highly valid and they are reliable. So this forms includes the 60 items in each, 120 items for both the tasks together, and then using the raw score, they have to convert the score with a standardized mean difference score and find the intelligence in overall intelligence. So coming to the result for adults with the ASD. So here, as we expected, there was a great deficit in effortful control because except for the activation control, they have the great deficit in total attention and inhibitory control deficits, as it was rated by themselves. You see, everything was lesser than p-value. I mean, the p-value is lesser than 0.01, which means a highly significant. So even for 10 and 13 children, we were able to see a very significant result in terms of effortful control in adults with autistic spectrum disorder. So now we know that both children and adults have deficit in effortful control. Now, the second question, the most hinging question is, what is the neural basis of effortful control deficit in autism? So in order to answer this question, we actually conducted the meta-analysis of functional magnetic resonance imaging studies. For those who are actually new to functional magnetic resonance imaging, I'm giving a little bit of information about it. So basically, the first figure here I'm showing is a Siemens 7.7 Tesla. Tesla means the amount of magnetic power in the machine. The more the Tesla power, the better the magnetic impulses, and so that the resolution would be greater. So in the second session, this is how usually the children or adolescent, anyone, if they put in the scanner, there is a head, there's a circle-like structure here, right? They have to go with this dome, and then they have to perform the task by whatever the task that we design. It actually goes on the screen behind of the magnetic coil, and then this reflection can be transferred to the attached mirror structure here. I'm showing the arrow mark here. And from that, the children or any person has to view the task, and based on the conditions, they have to perform using their hand. So this is how the fMRI measurement takes place. So basically, fMRI is a kind of non-invasive brain imaging method, which actually sends magnetic impulses to the brain. Probably you might have read about the paper that I sent you regarding the effortful control deficit in children. There we used FNIRS. FNIRS means functional near infrared spectroscopy. That's totally a different mechanism, because that instrument actually sends the infrared light into the brain structure, and then looking at the infrared light has the capability of absorbing and then reflecting on the structure, especially the particles from the blood. The blood consists of both oxygenated and deoxygenated hemoglobin. So when you send the infrared light into the blood cells, it actually captures how much infrared light is observed by the hemoglobin, by both oxy and deoxyhemoglobin, and then it takes the measure of how much it actually carries in a particular part of the brain. But in this functional magnetic resonance imaging, it sends the magnetic impulses. So basically, the blood consists of both oxygenated and deoxygenated hemoglobin. But in the oxygenated hemoglobin, there is an ion structure, and the I see I have mentioned here. Yeah, is here the third point. Oxygenated hemoglobin of blood contains iron. So this iron actually attracted by the magnetic impulse. So from that, how much activity is taken place in a particular part of the brain can be measured, because whenever we are engaging in a certain task, the brain actually recruits a lot of oxygen through the blood. So from that variation, the activity of the neuronal structures can be measured and then transformed into the data for our analysis. So this is how the overall principles taken place. So here, the brain activity is equal to the degree of magnetic susceptibility with the oxygenated hemoglobin, in short. So moving on, so we performed the so we actually here I have to mention we didn't perform this task for collecting our data. Rather, meta-analysis means it means we have to look at the studies using this method while performing the effortful control task, which relates to executive attention, flexibility, and inhibition. And we have to narrow down how many studies that we come across. We have to narrow down that based on some inclusion criteria, which I will tell you in a couple of minutes. And from that, we have to make what is a loci of the brain activation pattern. So here, we used Boolean search. So we used the keyword such as, so we don't want to miss any of the studies. So we used a very broad inclusion keyword search. For example, autism means we never use just for typing autism and then look for studies. Instead, we use the autism, ASD, or autistic spectrum disorder and autism spectrum disorder. Even for the synonyms and antonyms, probably make a effect of the driving studies. And simultaneously, we use the effortful control, temperament, cognitive control, and hot executive function as one of the other set of keywords as a task. And we also wanted to retrieve the studies which is directly related to brain activation and brain connectivity using only the functional magnetic resonance imaging, because there are some other imaging methods available, but they are not actually as deep as the fMRI. So that's why we tend to stick with this technique in order to answer for the research question too. So in this inclusion criteria, as I mentioned earlier, the fMRI study is measuring the whole brain activation, not just the region of interest based activation or connectivity. Instead, they have to look. They have to perform the whole brain activation. So the voxels will be very. Voxels means the spatial resolution in a brain. So that every 3 millimeter is considered one voxel, so that the brain would be pictured very neatly and effectively. So that's why we wanted to look at the whole brain activation during the easy task or components such as executive attention, flexibility, or inhibitory control in children in individuals with autism, not only just children, but also with adults too. And it has to be purely the experimental study that includes the control group. For exclusion criteria, studies with the non-fMRI or animal studies or review papers or book chapters that we deliberately excluded because they couldn't, they cannot share the data which is useful for our research question. And we also excluded studies without a control group because we wanted to make an active comparison between the people with the autism and the individuals with the typical control. So that's why we eagerly wants to have the control group with mentioning in the studies. And moving on, from this criteria, from these criteria, we had search in various databases, like 6 databases that I chose, like AIMED, Medline, PsycInfo, PubMed, Web of Science, and Scopus. So, all the stuff. We come across. So in total, we come across 4,983 three studies. And then after removing the duplicates and various other forms of exclusion, like studies chosen by screened by title, abstract, and then the full text, the final study yielded only 17 out of 4,983 studies. The eligible studies, which only which is only helpful for us to answer for the question we thought is only 17. So from that 17, there were 634 participants mentioned, and from that, ASD participants were 287, and typically developing children individuals are 347. The mean IQ ranged the 106.50 for ASD group, and the TD group 110.9. The mean age falls for the ASD group 18.87, for the TD group 20.93 years. So from that, yeah, this is the result what we retrieved. Because we, one of the criteria that we chose is a executive attention. I mean the effort to control, executive attention task, and then the inhibitor control and flexibility. So we actually wanted to skip, not skip. We actually wanted to look at the brain activation based on each task by comparing the ASD group with the typically developing individual. So here, for the focus task, for the executive attention, most of the people, out of 7 studies, almost majority of the studies are using the focus task. Here, this method is actually followed the activation likelihood method, which is one of the it is available method for comprising all the fMRI studies, as I shown in the picture below. So here, the peak coordinates of what we observed, the left dorsolateral prefrontal cortex for the flanker task, that is, which is responsible for executive attention skill. And the circle here showed as peak coordinates. It directly lies the left dorsolateral prefrontal cortex. And for the inhibitory control, similarly, the ASD group has more activation on the medial frontal gyrus and dorsolateral prefrontal cortex, minimal. And for the flexibility, the peak coordinates of what we observed using the during the stroke and subscription task were prefrontal cortex again, but also the anterior cingulate cortex. So altogether, the dorsolateral prefrontal cortex plays a huge role in terms of in terms of controlling the executive attention, inhibitory control, and flexibility skills. I mean the tasks. So here, we now know very clear about the effort to control deficit happens in children and adolescents with the autism, and the key responsible brain region is also we observed. The dorsolateral prefrontal cortex is one of the most eminent place region, which so we have to look at for answering the other question. For example, is the deficit of autism brain can be modulated? Yes, of course, we can modulate as per the numerous research studies shown in animal models. We can modulate brain activities based on electrical transcranial electric stimulation. This is basically a non-invasive brain stimulation technique by sending the low intensity electrical current. Some people might think electrical stimulation means the current stimulation would be higher, but unfortunately there is no such higher threshold current will be passed to the brain. Rather, it is a slow intensity electrical current which has 0.5 to 2 milliampere, which is very tolerable to the human's brain, both for probably above the age group of 14 would be much better. And basically, the transcranial electric stimulation consists of 4 different types. Number 1 is the transcranial direct current stimulation, and number 2 is the alternating current stimulation, and then the random noise stimulation, and finally the pulsed current stimulation. Let's take a look at one by one as we proceed in the session. So for the TDCS, this actually works in a in the same way as I mentioned. Yeah, there is a there will be another. Okay. Yeah, here in TDCS, it actually sends an electrical current using the anode. Anode means it actually sends the positive current to the brain cells, and cathode means it sends a negative current, current to the via the electrodes to the brain cell. So by doing so, if you could see the picture here, which shows in the line showed in the orange color. This is a TDCS anode stimulation. Here, as the current stimuli started, I mean, later on I will explain how the electrical current applied via the electrodes. Just imagine that there are some electrodes on your scalp, and through which the electrical input is going on. By doing so, the initial response would be the neuronal activity is started climbing up, and then it goes to the peak level and maintains the level until the duration that we set for. And then once we stop the stimulation, it comes down. So this going up scenario is called depolarization of the current, and then it is a maintenance stage, which I'm showing here, the part screen. And then once it maintains for a period of time, and then switch off the machine, it started coming down, which is called a repolarization of the neuronal activity. This is basically the electrophysiological response to the electric current on neurons. So here, the neuromodulation occurs as a result of changing neurotransmitters, because during the anode stimulation, the GABA, the GABA and the glutamate are the two important neurotransmitters, plays a huge role while making a stimulation on the brain cells. During the anode stimulation, it increases the glutamate secretion and decreases the GABA secretion. GABA means GABA aminobutyric acid. That is we all probably come across the various neurotransmitters in the brain cells. For example, glutamate is a excitatory neuronal transmitter, and GABA is a inhibitory neurotransmitters. And besides that, there is acetylcholine, endorphin, and there is another neutrophin. Other neurotransmitters exist in the brain, which actually helps for the people to for the neurons to communicate easily based on a task or rest that they have engaged with it. And in the cathode stimulation, the GABA secretion gets increased, but the glutamate secretion gets decreased during the neuronal activity. So that the blue one, what I'm showing here, is a response for cathode stimulation. Here, once the current started applying on the scalp, the initial session would go repolarizing and then maintaining for a while until the duration that we set. For example, 20 minutes means 20 minutes, 10 minutes means 10 minutes, and then start depolarizing towards the baseline. The baseline is 0. So this is the waveform for the the transcranial direct current stimulation. And moving on, the transcranial alternating current stimulation. Here, as I showed earlier, this one is a positive current. Positive current means using the anode, and then the cathode means the negative current. So in alternative current stimulation, the mechanism would be applied both positive and negative current alternatively in a fixed frequency. If you look at this picture, the fixed frequency means plus 0.4 to minus 0.4. So if you may wonder how to fix this frequency. Later on, I will explain to you because when we conduct the experiment, I'm going to share some of the interface of the software that we come across while stimulating the brain using this interface, the set of stimuli. So here, the alternating current stimulation actually helps us to training the underlying neurons in a certain frequency, because the brain actually tends to, even for the normal state, just by waking or doing nothing, just by seeing or relaxedly sitting, our brain tend to produce a lot of electrical activities. Brain means the neurons tend to produce a lot of electrical activities based on the stimuli that we come across. So from that, the people actually measured so many years ago. The hertz 12 to 13 would be responsible for anxious and hyperactive. For example, if any person is really anxious and hyperactive, when you pick up the person and immediately if you record their brain activities using the electroencephalogram, their frequency range would be in between 12 to 35. So if the same person is very relaxed, attend passively, that means if you check their neuronal activity using the EEG, probably their frequency range would lie between 8 to 12 hertz, which is an alpha stage. And if someone really sleeps very deeply, that means their person's brain activity, the neuronal activity range between 4 to 8 hertz, which is called the theta waves. And finally, the delta wave can be produced at 0.5 to 0.5 to 4 hertz, which is an unconscious stage, like a coma stage. If some people are in the coma stage, probably their brain activity falls between 0.5 to 4 hertz, which is not useful for this in the real life situation, but these three can be applied in the real life situation. So it means, so when you apply for the TACS, you can choose any of three, like beta, alpha, and theta, but not definitely the delta one, because it is an unconscious stage. So you can entrain the particular part of the brain based on this frequency by using this modality, like you called transcranial alternating current stimulation. So the range can be fixed in the software that comes along with the machine when we purchase. I will explain about it later. So moving on, there is another technique in transcranial electric stimulation, which is called transcranial random noise stimulation. This is really worse because I also personally experienced this one. I would say this one is really worse, and it's quite painful too, because it actually sends an alternating current at a random amplitude. For example, there is no in the transcranial alternating current stimulation, we can set the amplitude within this definitive range. So there will be a nice low in the current in your brain. You can feel that. But this one, transcranial random noise stimulation, sometimes it goes like higher and sometimes goes deeper, and sometimes you feel nothing. So yeah, this is like that's why it's like it's uncomfortable to feel, for me at least. So here we cannot use the fixed frequency pattern. So but researchers tend to use this technique because they wanted to entrain the random amplitude and also the frequency when when they are highly sedative or some kind of problems that they come across. So it's not much useful. I mean, it hasn't been used much in the research platform on human beings, but in the animals, yes, there are a lot of research papers are available using this technique. And finally, the transcranial pulsative current stimulation. This is another form of transcranial electric stimulation. Here, we can use the electric current intermittently. Intermittently means the machine, when you start the machine initially starts on and then automatically off, and then starts on automatically off. So it goes by until the duration that we said, for example 20 minutes or 10 minutes, like that. So here it goes, it basically is the transcranial direct current stimulation. It goes for a I mean the depolarization and the repolarization occurs within a specific time point, and suddenly there is no input, and then suddenly it starts. Like if we set the if we set the electric impulse goes through 1 second by 1 second, 1 second it off and then on, and then off and then on, like that. If we set for 4 seconds, 4 seconds it will be on, and then 4 seconds for off, and then 4 seconds on. So it goes until the time that we set up for stimulation. So this is a model for transcranial pulsative current stimulation. In my opinion, I couldn't come across anything on the people this one too, but there are a lot of these two methods are widely used in animal studies, but in the recent times, they started exploring the effect of TRNS and TPCS in human studies, but not much widely available. So now, coming to our study, so out of these four techniques, we tend to use the transcranial direct current stimulation, since it can directly change the GABA and glutamate receptors, which is one of the fascinating factor for children with autism becoming hyperactive. So we wanted to use this technique, transcranial direct current stimulation technique, in children with the autistic brain, how their brain responds will be, how their modulation takes place, and how's the effect of transcranial direct current stimulation on various neurocognitive tests. So we use this method. In terms of autism, there have been many studies available. If you look at the databases, only 3 studies so far you come across. The one is AutismHaryana group of research group. They published 2 papers in the very long back, 2014 and 2015. And then the Skinner and Hobb, they both are from Netherlands, and they also published 1 paper. Other than that, I couldn't see any noticeable research outcomes or papers based on the TDCS application in children or adolescents with autism. In that, even for publishing these 2 studies, I just saw they used only the single session annual stimulation, not for the cathedral stimulation over the left dorsolateral prefrontal cortex, that is F3. F3 means here is a in EEG, electroencephalogram, there is a system called 1020 International System. In that, the brain regions are marked based on certain landmarks. So this one is a F3, the red one, what I'm showing here, and this one is the F3 corresponding to the actual template. So yeah, once I applied the single session means like when the patient comes for not patients, when the participant comes once in a day and receive treatment, probably annual stimulation treatment for 20 minutes, and then they left, and then immediately they have to check the response, how the changes happens before and after. And by using this method, this research group actually found some positive effects on social health and behavioral domains of. This is for AIOTA is a anodal treatment effective. FTC stands for something. I'm sorry, I forgot that one. But this is a kind of questionnaire, and this is a CARS, Childhood Autism Rating Scale. Yeah, they found some of the positive benefits using this method, and Skinner and the Hawk group, they also found some of the benefits in language acquisition. I mean, the people who receive anodal stimulation over the left dorsolateral prefrontal cortex, they are able to producing words and rehearsing words efficiently as compared with the typical control. Yeah, although these two studies using the TDCS, anodal TDCS on children, on individuals with autism, it still lacks whether, how about like in occupational therapy perspective, we give treatment every day for children, at least not in every day, maybe once in a day, thrice in a week for few weeks, few months. So we wanted, if you wanted to check the effectiveness, if something goes like continuously, and then look at how much actual neural modulation happens within the brain. So we are enticed with this research question, but this one, these two studies lacks in that area. And also there were no neurophysiological tests or neuro modulation, like looking at the brain activation and connectivity and measuring them in individuals with autism. So we found that it is a literature gap, and I really wanted to explore this area. So that's why I set up my research in this area. So after finding this gap, I come across writing the proposal, and then that proposal has been simultaneously registered in the clinicaltrials.gov. It is a US-based, American-based National Library of Medicine. So it is always better that whenever you formulate any clinical trials, you have to register in a proper platform, so that people know that you are the person who are doing this research and you are the authorizing one. So we immediately registered, and it was published in 2019. So you can check that link by using, here I have to tell a little bit about the intervention. What we used is a clinical trial. The estimated enrollment, we are looking for 90 participants for autistic individuals, and it is purely a randomized control trial. Randomized means it's just by chance. Our group allocation is based on just by chance, not deliberately. We have to put one patient for cathodal, one for sham, and one for nothing. We couldn't actually choose in that way. Rather, it is a randomized. So so the effect cannot be effect would be the real effect, not someone has to manipulate the real effect with the personal favoring. Yeah, and then the yeah, this is a trial that we registered. Probably I can share this if some people are really interested in. I recommend for them to go through this one. I think I'm sharing now this page. Can anyone see this clinical trial page? Hello.
Yes, now we can see it, sir.
Okay. So I lost it. Okay, this is a clinical trial page. So this is basically from National Library of Medicine. Here I didn't mention so much of the details because it is time consuming. So I ask everyone, if you have any time, leisure time, you can go through this trial for my studies. This one actually consists of all the necessary items. What is active TDCS, what is sham treatment, and how the wait list has been allocated into each group. And what are the measures? If you look at the tabular view, yeah, here we not only we just use the FFL control questionnaire, but also the autism quotients and the social responsiveness scale and the Cantor test, and also the other neurophysiological and neurobehavioral tests too. So yeah. So yeah, you can take a look at when you have free time to understand more about this study. Yeah, right. Now we can go back to this slide. Yeah, and then, hi Rajesh, could you please turn off your mic?
Sure.
Okay, thank you. Yeah, coming to the procedure for our own study, we used the neuroelectric system because we already registered the trial here. So, and then we started exploring the stimulation pattern and looking at the other parameters for treatment. So here, what we used the cathodal stimulation of left dorsolateral prefrontal cortex in individuals with autism. The machine that what we used is called neuroelectrics, the one that I'm wearing on my head here. It is an 8-channel system. The StarStim 8 means it is a brand name, neuroelectric, under the neuroelectric company. 8 means it consists of 8 channels. So at the back of my head, if you look at the machine, it has to go the wires from this point to this point. There are 8 separate wires can go, which is called channels. In that 8 channels, we can use 2 channels for stimulation. That is one for cathode. The another one is for the return electrodes. I will explain it about it later. And then the other 6 channels can be used for recording the electroencephalogram activities. For example, if you wanted to look at the neuronal activities for brain function, you can simultaneously record both the EEG data of your own head, I mean own neurons, and simultaneously you can stimulate the brain. So this is the advantage of using this machine. There are other machines available, especially Sortrix, but they don't have this facility. For example, simultaneously record the EEG and stimulate the brain. Only in neuroelectrics, this facility comes. That's why we opted using this machine. And it is also very easier for the children, and especially for children and adults with autism are highly hypersensitive while wearing such kind of cap or using the electrodes, and even for this the electrodes what I'm wear on the earlobe. So these are very highly sensitive tasks. So if something like a handy portable means, probably the individuals with autism can tolerate during the experiment. So that's why we opted using these 2 machines. And yeah, in the treatment group, the electrode actually what we used is called a 35 centimeter sponge. So the one that we have 4 different types of electrode. The bottom one is a very small, and then the moderately small, and then the bigger one. This one is a rectangular one, which is quite useful for I mean, the size actually matters because if you go for very small electrodes, the intensity of the feeling of current intensity that entering into the brain would be greater. So you feel really uncomfortable. Even for myself, I couldn't tolerate using the small electrodes one after 10 minutes of treatment session. So, and then I checked that this one would be the appropriate one, especially for the I mean the people with autism, because they are very hypersensitive, and this electrodes, the 35 centimeter sponge electrode would would gradually spread the electrical impulse into the brain cells, and without any hinging effect or biting effect. So basically, we have to when you are doing this kind of experiment and treatment, you have to take this electrode and make it attached with the cable sphere. You can choose 2 electrodes, because we choose 2. One is for the prefrontal cortex left side, which is called the F3, as I shown in the picture above earlier. And the other one, what we used is here, that is called right middle frontal gyrus. This area, number 4, is mentioned right middle frontal gyrus, FE2. So when we use these 2 electrodes together, the electrical impulse of negative current will actually falls from here and then directly comes here and then go back here. So the proton and electron discharge would be neutralized by using these 2 platforms. It is quite technical thing. If someone is really interested in knowing this one, probably I can make a video in later days, and then I will send it to you guys. So, and then this is a montage system. We used 2 electrodes, as I mentioned, the left dorsolateral prefrontal cortex F3 region and right middle frontal gyrus FP2. And the control groups, they actually. I mean, all the procedures are the same for the control group, except the current stimulation, they receive only for 30 seconds instead of 20 minutes. But most of the other time, after 30 seconds, the machine automatically stops, and then it imitates that there is something going inside the brain. But actually, they don't. The current is switched off totally. That's a control group. And then the active comparator group, we also wanted to compare the treatment effectiveness between the treatment group and then the control group. Active control group, they neither receive the electrical impulse nor the control group. They just they are the autistic individuals, but they have to keep under wait list for the entire experiment, so that we can compare 3 groups simultaneously about the effect size. The intensity and duration was, we chose, because the TDCS can be applied from 0.5 to 2 milliampere. So we chose 1.5 milliampere and 20 minutes a day, which includes ramp up. Ramp up means it's like there's no effect, there is no electrical current passed initially. So just 30 seconds it goes up, and then after finishing the 20 minutes of session, it comes down without any electrical impulse. So that is called ramp up and ramp down. For the treatment, for the control group, for the first 30 seconds, it feels like some electricity is going, and then after the next 20 minutes would not be any impulses going into the brain, and then after 30 seconds there will be an electrical impulse coming. So that's how it changed from 1 to 1. And then yeah, we give 5 days per week for 2 continuous weeks, which consist of 10 sessions in total. So basically, we wanted to look at the effectiveness of transcranial direct current stimulation for 10 continuous sessions, and then look at the 10 continuous sessions, which has been split for 5 days per week for 2 continuous weeks. That's called repetitive transcranial direct current stimulation. Earlier, we saw only 1 single session treatment. We saw some of the research groups published a paper on that in 2014 and 2013. But this one is called repetitive TDCS. So here, unfortunately, also we registered in the clinical trials. We in July 2019, we started estimating our study. Unfortunately, in Hong Kong, there's a huge riots going on during this time, and we couldn't recruit so many subjects. And after that, in uh, in January 2020 and all, because of the corona, and then the pandemic started, our experiment is completely stopped for almost 1 year, and we just resumed, started collecting data 2 months ago. Yeah. Unfortunately, we couldn't do much of the data collection, but as of we collected, the ASD control group, I mean the ASD cathodal stimulation group for number 5, and the ASD sham group number 5, and then the control group. So we collected 15 patients, I mean 15 individuals with autism data, and from that, yeah, as mentioned, except for the gender, all age, IQ, and then the autism level, which has been mentioned by autism diagnostic interview revised scale. It has 3 different sections, like social interaction, communication, restrictive and repetitive behavior type. And by using the scale, all these populations were matched. So you can see the statistics here. So based on this, probably this could be considered as a pilot study. So yeah, we are still recruiting the patients, and yeah, we are, the treatment, I mean the experiment is still on, but we haven't collected full fledged of data so far. So based on the pilot study, the available data that we have, although we couldn't compare the between group result, the within group result showed a huge improvement, because the ASD cathodal group showed a huge difference in, not a huge, I mean the marginal difference in effortful control score, because before the treatment, so the blue color showed in the pre-treatment effortful control score, which is measured by the adult temperament questionnaire, and in that, before treatment, the ASD cathode group were around 2.5, and after the treatment, after 10 continuous treatment, we immediately asked them to fill up the questionnaire, and it goes up to 3.6 or 7 something, and it was highly significant too. The pairwise t-test showed less than 0.01 in the significant ratio, but there were the group that they received 30 seconds initial electrical input and 30 seconds end electrical input. They don't show any significant changes, but there has been some improvements in terms of 2.5 to 2.6, a little bit higher, but not as much as compared with the people who received the cathodal stimulation. But for the control group, ASD control group, they neither receive cathodal stimulation or sham treatment. They showed almost equal. There's nothing. There's no change at all. Even after 1 month of duration that they have. And yeah, we also looked at the dorsolateral prefrontal cortex activation. This activation, I think the people who are read my research paper, which I sent for pre-lecture reading, I mentioned I mentioned all the procedures and how to calculate the dorsolateral prefrontal cortex, how the data is collected using the functional near infrared spectroscopy. I provide everything in the research paper itself. So I didn't go enough for the details on the analysis section. So here, that's why I totally took at the dorsolateral prefrontal cortex on the left side, and the result showed a clear delineation. See here. Because what we found in the meta-analysis, the dorsolateral prefrontal cortex activity is highly hyperactive as compared to the typical control when they are doing the effortful control task. This has greatly, to be surprised, this has greatly been reduced. For example, from 2.4 to 1.6 something. So which is highly significant too. So, but as compared with other groups, treatment with the sham condition and treatment with the control condition, no treatment, the control condition, there's not much marginal difference. But people who receives the cathode stimulation, they have difference in recruiting the dorsolateral prefrontal cortex. And we also found the connectivity. Again, I informed about, I mentioned everything about how, what is connectivity means, or how it actually being calculated in the research paper which I sent you. So probably you can refer those papers if you are not able to catch up the point. So again, here the hyperactive connectivity in dorsolateral prefrontal cortex has been much reduced in the group who receives the cathode stimulation. But for sham stimulation, there has been a little bit different, but not statistically significant. But for the control group, yeah, from high, yeah, already there has been higher connectivity, and after a month of post intervention, not intervention, waiting period, we calculated and it goes even higher. So this suggests that the dorsolateral prefrontal cortex activation and connectivity is being modulated by the cathodal stimulation of transcranial direct current stimulation. I think the machine plays a huge role in terms of modulating the brain activity. So that's what, but still, it is a preliminary study. We couldn't make a firm conclusion just because of doing 5 cases, and we didn't compare because of the small sample size. I just used the within group comparison. We didn't use the between group comparison. For example, how the effect actually happens between cathodal, sham, and control. Probably after collecting the whole full-fledged data, the between group comparison will be included. But now, because of the small sample size, it is not much interpretable by using that technique. I mean, by using a between group comparison. It's not much meaningful. So just we stick with this as a pilot study result. And from this, what we come across, the cathode stimulation probably induce a positive effect on effortful control by modulating the brain activities. However, it's just a preliminary study, so we cannot make a firm conclusion based on this. So to conclude, our take-home message is for this entire presentation. The EC deficit affects the social emotional skills in individuals with autism that we saw earlier from my 2 researchers that I shared with you. One is the children with autism, the another one is adult with autism. Adult with autism paper is just being written, so it hasn't been published. The one, and then yeah, from that children with autism evidence that we have, probably incorporating the early intervention for underlying the EC components, not addressing the full components. So probably the executive attention might be warranted. If they develop the better EC skills in the early intervention process, probably it might help them to become the successful person in the later life. And then the other question that we look for, the dorsolateral prefrontal cortex subserves the EC function, which hasn't been explored. And this research paper is under peer review. Probably in a couple of weeks it will be published. So yeah, it is a definitive result. And this one, the repetitive TDCS cathode stimulation, probably influences the effortful control function by just inhibiting the dorsolateral prefrontal cortex activities of children, individuals with autism. However, we cannot make a firm conclusion yet because it is under a preliminary stage. So we still have to wait for a period of time until the full data collection being gathered, and then we publish the result. Yeah, so that's it. Thank you very much for all of you who participate in this research lecture. Happy New Year to all. If you have any questions, please let me know. I'm welcome to answer for your questions.
Yeah, we are open for the questions now. If anybody would like to ask any questions or have any queries with the presentation, they can raise up their questions now. Okay. Karthikeyan sir, can you hear me?
Yeah. I'm
Cool.
hearing you.
Okay, so yeah, I think yes, I'll just check the chat box also if we have any questions. As far there are no questions, but sir, all the viewers have appreciated the presentations and have thanked you for your well explained presentation. Even on the Facebook live page and on the chat box as well. And since even I have a background in MOT neurology and I'm primarily dealing with autism, I would like to say that the presentation had great intellectual depth and volume. So it was quite enlightening for me as well. Thank you so much for your presentation, sir. I just want to ask one question, that what the procedures that you were using with autism kids while you're fixing the different electrodes. So we have seen that kids with autism are very sensitive to investigation protocols. So did you use any strategies to make it more acceptable or comfortable for them during the procedures?
Yeah. Basically, they are going for the occupational therapy treatment. Here we have a very good setup. And then we look at the time schedule in which the children and the adults in autism are capable of taking the new stimulus. So we conducted the parent experiment too, the questionnaires, and based on that, we set up the time with them. Yeah.
Right. Okay. Thank you, sir.
Yeah.
Sir, there's one query from the chat box. Sumitra Paul ma'am have said that if we can get back to you regarding this research, can we connect you via email? So if
sure. Yeah.
If you can just
share
your email on the chat box, so if people can get back to you regarding the research.
Yeah. Hello, sir. Actually, I'm a parent, but you explained it so nicely that I'm really getting very much interested. So if again, I have to revisit the live again and again, then I have to understand this. If there is, and I know there is so lots of query will be coming out from this. So that's why I want to connect to you via mail. That's why I'm asking this.
Sure. I already sent you the email address.
Yeah. Okay. Thank you so much, sir. Thanks a lot.
Yeah. Welcome.
Hello, good evening.
Sir, I would like to, go ahead, ma'am, go ahead.
Yeah, I am also a parent. I just want to know, my daughter she is intellectual disorder child and she is having mild atrophy. So is there any possibilities to get rid of it through this treatment?
Oh, this treatment is actually in the research phase right now. We are exploring the effects of various clinical populations. Probably after the research with the children, I mean individuals with autism, we can explore about a different population. But as of now, it has been approved for the clinical purpose right now because it's very, very new.
Okay. And if we want to be a part of it, what are the procedure we need to follow to be, means, I think, I mean, as long as per as your research work, whatever I came to, means I am feeling like it will give a positive effect to our children,
Yeah, yeah,
because
yeah.
the stimulation, what you told, is very much effective for, means when I do the meditation part,
Mm-hmm.
as the meditation is helping me when I am having disturbed brain, so this kind of electrical, means frequency, may help my child. So
Mm-hmm.
if I want to be a part of this, what I have to do, means, as because I am staying in Bangladesh,
Mm-hmm.
it will be very difficult for me to means, to be a part of your means part of your experiment.
Yeah, 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 yeah. I understand. Uh, yeah, we will update you as soon as we publish the paper and make it as a
Okay.
clinical use. We will update you through Manish. Yeah,
And wish you all the best for your this experiment. It will truly, if it will be coming in a positive way, it will definitely help us, inshallah.
yeah.
Thank you for
Thank you.
everything.
Yeah, welcome.
If we have any more questions, the platform is still open, and we are taking up more questions. If anybody has questions, they can raise it up now.
Karthik, anybody from
Yeah.
India participating in this study, or any such study are being done in India as well?
No, unfortunately, no. Because it is earlier we used to have a collaboration with the Harvard Medical School. In that, I saw a couple of parents from India who also participated, but in India itself isn't been established yet.
Okay.
Yeah.
Thanks.
Yeah, welcome.
I think so. We have covered up all the questions and the viewers' queries now. And I would like to inform you that we have reached more than 600 in number on the Facebook Live page, where people are actively attending the live presentation on our page. And on behalf of Manish sir and Haryana chapter of AIOTA, I would like to convey my regards and thank you for taking out time for our platform. I know it's a pandemic times, it's a busy schedule, and you have proactively reached out to us and been very active in delivering your content. So thank you so much for that, and we wish to take it further in the coming weeks. And if you can take out more time, and people are more interested in such neurological evidence-based practices for the kids on the spectrum. So thank you so much, sir, and we can call it a day. Happy New Year to everyone.
Yeah. Happy New Year too, and welcome. And thank you for my all these things.
Thank you, sir.
Yeah.
Thank you, sir. All the best for your research, sir.
Yeah.
Thank you.